Hey, welcome to the first lecture. This class will serve many purposes. We have 24 students in the classroom this semester, so I'll certainly be addressing you folks as if we're just a separate class and nobody else is watching. But let's all be aware of the fact that this will be watched by people on Raleigh Cable Channel 18 about a week from now. During the dinner hour. That'll be actually fairly nauseating for them to watch it in 6:30 in the morning and 6:30 in the evening. I apologize for that. Then, after this semester, it rolls to DVD, and students from several semesters will be watching it on DVD. So just be aware of that. We have microphones. Your questions can be heard. It'll be a little awkward at first, because, you know, it's all the lights and we got cameras in each corner, and but we'll try to, as much as possible, operate like a normal classroom. I'm not used to sitting, personally, in teaching. I like to move, but we have limited blackboard space, and I like to write a lot. So I'm not going to use the blackboards. I'll use this little overhead camera to do most of what I write in class. So I'll address your schedule, your test dates, your Maple due dates, your web-assigned homework due dates. If you're watching this on cable TV, those don't apply to you. If you're watching it on subsequent semesters on DVD, those probably don't apply to you either. So don't pay much attention to due dates. Even places where we break the class up into tests, test 1, test 2, test 3, those may not be the same as the DVD course. So check what I call a pacing guide that you receive on DVD. That pacing guide will be your guide to when your tests are and what your tests will cover. So it'll be a little confusing at first because I'm addressing 3 audiences, but after a while I'll just address you, and we'll just treat it as a normal class. Does everybody have a syllabus? Everybody has a syllabus. It should be front and back. So the schedule of days and tests and those kinds of things are reduced 2 pages to 1 on the back, so you can kind of keep track of where we are and where we should be in the course. The front is kind of how my classes typically operate, although this is a little different because of the studio classroom. You know the text. It's calculus, concepts and contexts. There are a lot of versions out there. This is the 3rd edition. I think the copyright is 2004. Might be a little newer than that. James Stewart is the author. So if you don't have that, get that. It's not cheap. I don't know what it is now. Last year it was $120. It's probably about $150 now. Is that about right? Yeah. Is that new? $150? Anybody bought a new book? It was around $150. Anybody buy a used book? What was the used book?
Like 100.
100? Oh, that's a bargain, right?
Like that.
Well, it is a little bit of a bargain, because if you're doing the 3-semester sequence, this book is good for 141, 241, and 242. So take the purchase price and divide it by 3, and that's what it is per course. And some people choose to do 141 multiple times. Then you get to divide it by 4 or 5, or you do 141 twice and 241 2 or 3 times. I mean, then it really becomes a bargain. It'd be like $5 a course. But I don't suggest that route. So keep in mind that if you are doing the 3-semester sequence, that although it's not an easy course, but there are sequels to this course, and we've got to get to a place where I feel comfortable sending you on to 241, and you want to get there too. I don't want to create gaps in the learning. I don't want to skip stuff that you're going to be responsible for in 241. So if it seems like the pace is a little too quick, we do have a target to head to, and I want to get there so that you're adequately prepared for 241. And you want to get there too. Although sometimes you'll battle me a little bit. Goals and objectives, you can read through that. That looks like a whole bunch of things. that is a whole bunch of things on the goals and objectives. Intermediate value theorem, Newton's method, L'Hopital's rule, Riemann sums, integration by parts, integration by decomposing into partial fractions. Does any of that make sense? How many of you have had some calculus before today? Okay. That's great. I'll teach this class as if no one has had any calculus. But if you've had some, don't let that lull you into this malaise that, oh, I've had that before, I know how to do that, I'm going to tune him out, he's annoying anyway. Don't let that happen, because there is research out there to say that if you take calculus only to repeat and take calculus again, like from high school to college, that you actually do worse than those who have never had calculus at all. So, and I think part of that is that you get lulled to sleep. So are you registered for the class? Mm-hmm. So somebody in here, oh, we have a seat? Oh, yeah. Okay, there we go. Here, pass that back, would you please? Now we've got everybody. Yeah. So I'm used to teaching classes of about 150. So this is like a treat for me to have just 24. I've actually taught a class of 292 here on campus. Wow. That's a lot of people. So this is a treat to have a small class. How will you be graded in this class? 60% of your grade will come from tests, 10% from homework and quiz. Homework is delivered to you and submitted by you on WebAssign. It's an electronic homework delivery submission system that was actually developed on our campus that is now a separate enterprise that you have to pay for. I apologize for that. That you have to purchase access to WebAssign in addition to the book, and you have to do that each course. You have to kind of repurchase WebAssign. Two features of WebAssign that I really like. It does, actually three features. It does use problems from your book, as you would guess, since the answers to the odd-numbered problems are in your book. It chooses even-numbered problems from your book for you to work out. Sometimes, though, it's helpful to do the odd problem on either side of it, and you do have the answer to check, and it might give you a clue of how to do the even-numbered problem. So keep that in mind. So it is problems from our book. It does give you immediate feedback, so when you submit your answers, within 5 seconds you'll have a graded homework in return. Just a second. And the other feature that because I might forget because I'm getting kind of old, the other feature is that you have multiple submissions. So if you don't get it right, you can figure out what you did wrong, hopefully, and resubmit it. And a lot of students that I have in class at the end of the semester, they'll have 100% in WebAssign or nearly 100% because you get a chance to work to perfection. I like both those features, the immediate feedback and multiple submissions, because what's the goal? The goal is for you to get some practice with the stuff and kind of make sure you get to the point where you know what to do. Question?
Well, you kind of answered it, but so you get penalized if you get an answer wrong?
No. Now, there are different ways, that's a good question, that faculty will handle WebAssign. I personally don't care if you get it right on the first try or the second or the third or the fourth. My goal is that you get it right. So you'll get the same amount of points whether you get it right on the first one, 7th one, or 10th one. But it can operate on a reduced point value, and some of your teachers might do that, so you need to check and make sure that if they're using WebAssign, how is it counted beyond the first submission? Yes?
How much is it? How much does it cost?
Oh, has anybody purchased it yet? About $12.
$11.95.
How much?
Like $11.95.
Okay, about $12. So, and I formally apologize that is the case, but if you could imagine, even in a class this size, 24 students, if I were to collect your paper and pencil homework and then grade it, the only way that it would probably work is if I had it graded the very next class. If it took me a week to grade it and returned it to you, we're so far beyond that in a week's time that it kind of is meaningless to get it back a week later. So the immediate feedback and the multiple submissions, even though it costs you $12, I think you'll like it. So that'll be homework. We will have some quizzes in here. I will announce when the quiz is going to be, so you'll be prepared for that. Those all roll into one little basket there, 10% of your grade. Final exam in this class is 25%, fairly significant chunk of your grade. For the DVD people, their final exam will be worth 30% because they don't do MAPLE, and your MAPLE is worth 5%. So there are 5 MAPLE homeworks for you guys, so it's kind of easy to keep track of where the 5% is going to come from. Question?
Do you know when the final exam will be?
Yes, it is at the bottom of the page. Friday, December 12th. So that's the first week of exams. The last day of the first week of exams, 8 to 11, in this room. Unless they tell us differently that this studio classroom is needed for some other purpose, and we could go in Harrelson or somewhere else. But right now it's scheduled for this room. There's the grading scale. We'll use plus-minus grading in here. Basically, if you take a 10-point subdivision there, let's say the B range, 88 and 89 are B plus, 80 and 81 are B minus. So the top 2 are plus, the bottom 2 are minus, and everything in between is the straight letter grade. And it pretty much operates that way except for the 90s, because we have that extra grade there, the 100, it's also an A plus. Absences. No penalty for excessive absences. I guess you penalize yourself because you may not know what's going on. The reward for good attendance, 5 absences or fewer at the end of the semester. It seems like a lot, but it is fairly forgiving, I think, is the opportunity to replace your worst test grade with the final exam if your final exam is higher. So if you get a 45 on test 2, all of your other grades are in the 80s. You get a nice solid exam grade of 88, then that 88 counts for your final exam, and it also replaces that ugly grade you had on test 2. I don't know. Students have liked that policy in the past. It's a little forgiving. I used to drop the worst test, and I think that was kind of a mistake, because people would get to test 4, and you still might do this, so let me caution you against it. You say, well, I've got one test that I can blow because I'm going to replace it with the final exam anyway. That's not wise, because that material from test 4 will also appear on the final exam, and you didn't master it for test 4. You probably will not have done that by the time the final exam comes around, and it ends up biting you twice. So I would not advise that. We've talked briefly about the studio classroom. I can tell in your faces that you're ready for me to kind of, let's get on with the math. I want to do the math. That's why I'm here. I can read faces, so I know that's true. It is a studio classroom. There's a microphone between each 2 desks, so if you have fidgety habits like tapping a pencil or snapping your pen, please be aware that those are being heard and probably annoying the living daylights out of somebody. Please don't cover the microphones or make any unnecessary noises. No sleeping. If you're sleeping in here, you're absent. Plus, it looks kind of bad on TV. You know, oh, wow, they're sleeping in there. That guy's really doing a good job, isn't he? So none of that. If you're going to sleep, you're counted absent, so just go ahead and stay in your dorm room. It's probably more comfortable than the desktop anyway, because in both cases you're absent. And I had to add this in. I'm sorry. If if you have bedhead, because it's going to be seen on TV, your hair is just really nasty someday. You didn't have time to wash it, or some of you guys that never wash your hair, and your hair is like this, all spiked up. Not without the gel. I mean, just because it's nasty. Wear a hat. Okay. If you have bedhead, wear a hat. No food or drinks in this classroom. Homework and quiz is WebAssign. WebAssign website is at the bottom of this page. Students with documented disabilities, make sure you get that paperwork to me. If you get extended time on a test, or you get to take a test in a distraction-free environment, those are legit. I'm not going to question them. You've registered through Disability Student Services. Make sure you get the paperwork done and get it to me prior to the first test. I can't accommodate you without that paperwork. We'll take tests in blue books in here. I should have brought a blue book. The reason that you take them in blue books is, well, there's two reasons. One is the pages, it's a little booklet, has about 8 or 9 pages in it. I won't lose pages from your test if you turn it in a blue book because they're stapled together on the little binding. The other reason is when you have done problem 1 and you turn it over, it is no longer available for viewing for anybody around you. That's the other reason that we'll use blue books. So I want to make sure that you do your own work. There's the academic integrity statement. It is a very ugly situation because I've had to deal with some of them. People not doing their own work, they can get ugly. We can settle it in the math department, or we can go to the Office of Student Conduct and they do a super job, but you don't want to have to do that. I do have a web page. The link is here at the bottom of the page. And I do post some old tests there. There are some there now. I'll take a look at them over the next couple days and make sure they're kind of a fair representation of what old tests should be. But that'll give you an idea of what has been asked in the past, how it was asked. I also post the solution so you can see what the solution was. Schedule on the back. Again, for the DVD people, pay attention to the pacing guide that is emailed to you for your kind of how your class will run, whether it's a regular fall or spring semester or the 10-week summer class. Okay, Maple is in here. I'll talk a little bit more about Maple off camera because it's relevant to you, but not necessarily to the cable people nor the DVD people. If you look at the schedule, it says that 1.1 from the book all the way up to and including 1.4 in the book are prerequisite material, pre-calculus review. We'll do some today with those sections, but today is going to be all we're going to do with the prerequisite material. And if you look back at it, which will be kind of your main assignment prior to tomorrow's class, is to look back at these typically, or basically the first 3 sections, 1.1, 1.2, and 1.3. And if there is anything in there that is not completely review for you, and I did not address it today in class, let's start class with that tomorrow so we can get that cleared up, get everybody on the same page, and then we'll advance. 1.5 is exponential functions, which is probably review for most of you as well, but we will kind of start this class with 1.5 and a section from the back of the book in the appendix has some coordinate geometry. But the first 4 sections should be review, and make that your assignment. I mean, you paid a lot of money for the book, so I would advise you to use it. It's a good book. We've used it for a number of years here, and each time it goes to a new edition, we look at all the competitors' books. I mean, they want us to use their book because that's a lot of books. A lot of people are taking 141 right now. So we look at what else is out there about every 3 to 4 years, and this one, although we have used it for a long time, we look at the others that are out there, and it is a very good textbook. It is a good mix of kind of traditional calculus teaching and learning, kind of what was taking place 20 years ago, and contemporary methods where you look at things multiple ways, verbally, visually, algebraically. And in fact, why don't we start with that. So your authors will do a good job in this book, the author, I'm James Stewart, of representing functions. Some functions it's appropriate to look at them all 4 ways. And this is kind of more contemporary teaching and learning methods as opposed to a traditional old-fashioned method. Verbally, let's describe a problem, see if we can model it mathematically. Numerically, we might have a table of values. So you may not have a picture of this nice smooth function. We have a table of values. Maybe we can see what's going on in that function by the fact that we have some numerical values. This is two-dimensional calculus, by the way. So we'll be working in a plane, XY plane. When you get to Calc 2, you're still in the XY plane, still two-dimensional. When you get to Calc 3, 242, you'll be working three-dimensionally. But we're in two dimensions now. So y will be represented as a function of x. Visually, you might be given a graph and asked to analyze some things about it. What's the maximum value of the function? What's the minimum value of the function? Is there a point of inflection? What happens there? How do you know that if it was a potential point of inflection, how can you look at a graph and see that it actually is a point of inflection? And probably what we're all most used to is algebraically. So we have a formula. We create our own table of values, we graph it, we get a picture of it, and then we try to say, well, what is it that might be pictured like this? Is this a population growth problem? Could this be an exponential decay problem? What is this, possibly? So that's the four ways that functions are represented in your book. Let's take a brief tour through the first, actually, three sections. Section 4, if you look at it in your book, is a graphing calculator section. You probably know a lot more about your graphing calculator already than this textbook is going to tell you. So if there's something you don't know and you want to use this as a point of reference, that's fine. I probably won't spend 30 seconds in section 1.4. You know how to get the things graphed and pick off the intercepts, and it's too small and you want to open up the window. You know how to do those things.
Is there a specific calculator that we need for this course?
No. I think I prompted you with questions today because your questions are kind of exactly what need to be asked to this point. A graphing calculator is not required in this course, first of all. So you don't have to have one. I use a scientific calculator. So I think you really need a scientific calculator. If it does exponentials and logs and trig, you're in business, okay? And those aren't very expensive. So if you don't have at least a scientific calculator, you need one of those. Graphing calculator, TI 83, 83 plus. Here's what's off limits. And this is this classroom and any subsequent people that take this class on DVD. Is if your calculator does calculus, it's off limits. Okay? And I mean, you can figure that out. I'd kind of really rather know what you know. Do you know calculus rather than your machine? So that's a TI 89. You can't use that on a test. TI 92. Or any other calculator that you have been able to program some subroutines to do symbolic manipulation, derivatives, and or integrals. Those are off limits. Okay? So calculators are fine, but I want to know. You're going to be tested on calculus, so if your calculator does that, you can't use it on a test or a quiz. Yes, sir?
TI-86 does function integrate. Is that?
If it does integration, then it's off limits. So check out your calculator and see what its capabilities are, and you can't say, oh, it does this, but I'm not going to use that button. No, doesn't work. Okay, because I can't monitor you, all 24 of you, or certainly everybody taking this course in subsequent semesters. If it does calculus, it's off limits. All right, so 1.1 through 1.3. What we don't get to today, that's your assignment, to take a look through those sections and decide what it is that is not review for you. Bring that up first thing tomorrow in class. And we'll talk about it briefly because we've got to kind of go ahead, and it's intended to be prereq material. And don't be embarrassed to bring it up if it's not prerequisite material for you. We'll address it quickly and move on, and maybe you can spend some more time on it yourself, but let's at least address it quickly if it's not review for you. The first section, author talks about 4 ways to represent a function. We've already looked at those. So let's talk about what a function is and why that is critical in mathematics. But let's take a step back from what a function is to what a relation is, because a function is a relation. So a relation is what? First day, right? I guess I need to fill these in myself on the first day. A relation is any set of ordered pairs. So if there's something there, set containing 0, 0, 1, 2, 8, 7, negative 7, 14, if there's something there, then it's a relation. If there's nothing there, it's not a relation, it's an empty set. So, but if it's a relation, any set of ordered pairs. Now, for a function, we want to specialize this set. We want to talk about certain types of relations. I said I would fill these in myself today, but I just can't help myself. Somebody tell, what do we do to kind of any old-fashioned relation to make it this special thing called a function?
Give us variables.
Okay, we do something with the variables, so that's a start.
An equation.
Okay, we could put them in the form of an equation. They don't have to be.
You give it one value.
Okay, now we're hitting on the right topic. One value. So how does the pairing?
One value of x is the value of y, something like that.
Okay, that we want for every x, we want it to have a unique y value. Does that sound familiar? Mm-hmm. Okay, so it's a relation. For which each x value is assigned a unique y value. So let's go back up here to a relation. So we've got a set here that contains 1, 8 and 1, 5. Okay, I already said it's a relation, so I'm not going to ask that question. Yes, it's a relation, because there's something there. There's some points there. Any set of ordered pairs. Is that relation also a function?
Yes. Yes.
Yeah.
No.
No.
Each x value, how about each x value, is assigned a unique
Y value.
y value. Okay, be helpful if I actually wrote down the definition. The x value 1 is assigned 8. Is the x value 1 ever assigned anything else other than 8? There it is. 1 is also assigned 5. That's a problem. 1 is assigned 8. 1 is assigned 5. So is the x value 1 assigned a unique y value? It is not. So that is a relation, but it is not a function. So visually, if something is not a function, how do those points appear on a graph?
On top of each other.
Okay, or in the same
Line.
line?
Vertical line.
Vertical line. There we go. Same vertical line. So if you looked at the points, one 5 and 1 8, they are in the same vertical line, and we don't want that to happen if it's a function. So what's wrong with that? What's wrong with points being in the same vertical line? Why is it that math teachers, especially math teachers, make such a big deal about functions? Why don't we want points to be in the same vertical line? Those are nice. I like those.
Isn't it?
Kind of stack up there real nicely, kind of neatly, right? What's wrong with
It needs to
that?
have like a slope. Or
Okay, slope with regard to these 2 points is an issue, right? Because slope is the difference of y's over the difference of x's. And what's the difference of the x's? Well, there isn't any difference in the x's. So the difference of the y's would be 8 minus 5 with regard to these 2 points. The difference of the x's. So slope is an issue. with 2 points in the same vertical line. So there's one reason why we don't want that to happen. 3 divided by 0, undefined is probably what we'll call that. It used to be called no slope. That's horrible. It's a horrible name. No slope. If you have no money in your pocket, what do you have, undefined money? No, you have 0 money, right, in your pocket. So this is undefined, okay? And if 2 points have undefined slope, they're in a vertical line. In a lot of cases, that creates a problem. Why don't we take a little side venture here? Talk about division by 0. In fact, let's talk about 0 in a fraction at all. Let's talk about 0 over 3. What is 0 over 3?
0.
It is 0. And in fact, any division, let's take this back up here and say 8 divided by 4, which is 2. How could you validate that division? How do you check that division?
4 times 2 is 8.
Okay, multiply. So you take your, what, your quotient, right, times your divisor, and then you ought to be back to your dividend, right? So 2 times 4 is 8. Okay, does this check out okay? 0 times 3 is 3, so it does check out the way fractions should check out. Here's the problem with 3 divided by 0 is that, let's say it has an answer. I don't know what the answer is. We'll just make up a Greek letter alpha. What are we saying then is true if 3 divided by 0 has an answer? Right, some number times 0 is 3. That's the problem. Right? I don't know what that number is. Does anybody in here know what that number is? Because you and I need to change places. I'll let you teach the rest of the semester, and I'll just sit and watch because you know a whole heck of a lot more than I do. I don't think we have a number, right, that we multiply by 0 and get 3. So division by 0 is a bad situation. It's completely undefined. So we don't know what that value is, and we're not going to find it this semester. Even worse than that. How can it get worse than that? We'll contend with this in this course.
Infinity.
0 over 0. Gosh, that's really bad. Today, there's a special. Today, the answer is 7. Does it check? Checks out, doesn't it? Because my quotient times my divisor is, in fact, the dividend. So it does have an answer. And in fact, worse than that, it doesn't have kind of any answer you want to give it. How about 71? Is that also an answer?
Yep.
That's an answer. 714? Does that check out? Negative 714? This is even worse. So 0 divided by 0, at least with division by 0, 3 divided by 0, it doesn't have an answer at all. I can kind of wrap my hands around that. This one has all kinds of answers. So 0 divided by 0, and let's not make the mistake this semester of saying because the numerator and the denominator are the same, that's equal to 1. It is equal to 1, but it's equal to a whole lot of other things as well. So this is called an indeterminate form. And we will, is everybody able to read, okay, what I'm writing? Would it?
The script is a little hard to.
Okay, script. Okay, I'll switch to, I knew that. I should have not been writing in script anyway. I'll try to print because my printing is actually better. An indeterminate form we will address in this class. Whatever you want 0 over 0 to be, I could give you an example of a problem that has 0 over 0. If you want it to be negative 5, I can come up with an example where 0 over 0 is negative 5. Okay, here's an example. Limit of negative 5x over x as x approaches 0. How many of you are familiar with limits? You've used limits before. Okay. Well, we'll kind of go back to square one on limits in this course, but I just want to kind of come up with a quick example of 0 over 0. Now, if you put 0 in, we're really not supposed to let x be 0. We're supposed to let x approach 0. But if we put 0 in, what's the numerator?
0.
What's the denominator?
0.
So it is 0 over 0, right? Everybody agreed? But if x is not 0 but very, very close to 0, could we reduce x over x and say this is negative
Yeah.
5? Here's an example of where 0 over 0 is negative 5. Because you never let x actually take on the value 0, you let it approach 0. So whatever you want 0 to be, we can come up with a problem that will allow that to happen. And we'll visit that later. Domain and range. So we've got this list of points. I'm hoping this is review. Where's the domain? Where do we find them?
Value.
Okay, the first coordinate of each ordered pair, right? What we typically call the x value, but it may not be an x value. Be prepared for that, by the way. We're very used to x comma y or x comma f of x. That's very common. We probably overuse that. It's probably our fault as math teachers that that is overused. But we're going to have sets of points that are time and position or height or distance. We're going to have time and velocity. So be prepared for a lot of different things to occupy the first position and a lot of different things to occupy the second position, not just x's and y's. So the set of all the first elements are your domain. Range would be the set of all second elements. If we are given an algebraic representation of a function, let's say that f of x is negative 3x squared plus 5x minus 8, and we want the f of 1. What are we really searching for here? What is the f of 1?
Coordinate.
It's a y value, right? It's the other piece to the ordered pair, or the coordinate. So, and how do we get the f of 1?
Plug it in.
Plug it in. Whatever is done to x is now going to be done to 1. Does that make sense?
Mhm.
So I do claim to be a mathematician, but I am certainly not an arithmetician. So any help and all help I can get doing arithmetic in here is welcome. Okay? So what do we have?
Negative 6.
Negative 6. We get agreement on that?
Yeah.
So that gives us the ordered pair when the first element is 1, the second element is negative 6, right? That's what we found. We found the second piece to this ordered pair. This might seem a little silly. How about the f? Of course, half of the stuff we do in here is silly, so get used to it. How about the f of a?
Negative 3.
Okay, you do the same thing. We can't simplify as much as we simplified that one. In fact, we really can't do much at all with that, right? It still is an ordered pair when the first element is a, the second element is. So it's an ordered pair, but we can't do the computation because we really don't know what a is. And where are we headed with that? This is a pre-calculus concept, but it's very critical to some very important things in calculus. We need to be able to take the f of x plus h. So our function is negative 3x squared plus 5x minus 8. How do we take the f of x plus h? Plug it in, right? Wherever there was an x, we now replace it with x plus h, that whole quantity. So negative 3, instead of x squared, it's that whole thing, that sum squared, plus 5, where it was 5x, now it's 5x plus h. And does that look like the same function? That's the same function. We now have replaced x with x plus h. Does that, everybody feel comfortable with that? Okay. In some cases, we're going to have to expand and simplify. So let's go ahead and do that because that's going to be useful to us to make some simplifications. So we want to square the x plus h. Isn't that x squared plus h squared?
No.
No. See me after class if you thought that was a true statement when you have a talk. X squared plus 2xh, got that middle term, right? When you square a binomial, you get a trinomial. Distribute that 5. Don't forget to do that. Simple as that is, that gets forgotten sometimes. How about minus? So that is a very kind of ugly looking response to what is the f of x plus h. So in a lot of problems, that's not the end of the problem. That's part of what we need to do to get to the end of the problem. Okay?
You didn't change the 6 to the negative.
X.
Negative. Thank you. That won't be the first time we need, so you guys stay with me on this stuff. I'm going to make mistakes, but please don't let me leave it up there as correct when you know it's not correct. That doesn't hurt my feelings at all. So what do we have? We have this x value, or this first coordinate of x plus h, and we've got this ridiculously ugly second element, but that's it. That is the f of x plus h. Now, where are we headed with this? I hope this looks a little familiar to you from a pre-calculus class, and many of you have taken calculus. This problem happens to be a slope. So it's the difference of two y values. Do those look like y values? The f of x plus h minus the f of x, those are y values, or second coordinates, second elements. This hopefully looks like the difference of two x values. And in fact, we could have a picture where here is the point x comma f of x. Here's another point. Where the x value is x plus h, its corresponding y value is the f of x plus h. What if we found the slope? Isn't it this? There's y value minus y value. There you see it. X value minus x value. There you see that. So it's a slope. So you can see how this finding the f of x plus h could be in the background of a problem that is very important to us. You say, well, that's a curve. Curves don't have slope. Yes, they do. Curves have slope. They have variable slope. So this slope of this curve is different right here, and it's also different right here when I go through these 2 points. It's also different right here. So the slope on a curve is varying depending on where you are on that curve. But curves do have slope, so that will become important for us. Let's do one more thing. Say we wanted to make a sketch of this. You should have a set of functions that I think are fairly common to you. I mean, you might refer to them as a library of functions. So in your own little personal library of functions, what do you have that might help you to graph this thing? What's a simpler version of what this thing?
Parabola.
Just a simple parabola. What's the most simple one you can think of?
X squared.
Y equals x squared. So you know what this looks like. So that can possibly help us graph this. 0, 0, 1, 1, 2, 4, We've got symmetry going on here. So we've got this old friend. It's not an old friend, it's at least a really good acquaintance. So how do we take this old friend and come up with a sketch of something that looks like this?
Move it to the right one.
Okay,
And
so
up
the
4.
fact that, hang on a second, the fact that 1 is subtracted from x before it's squared has a net effect of moving the whole graph right 1, is that correct?
Wait.
And how about this little plus 4 that's tacked
Up
on at
4.
the end?
Up 4.
That's going to move this old friend of ours up 4 units. So if we go right 1 and up 4, that point should be the vertex, right, of this new version. Same shape exactly, just pick it up, lift it or move it to the right 1 and up 4 units, and we've got this new version of the function. Some of you are hesitant. I could see it in your faces. Right 1. Subtraction of 1 has a net effect of shifting a graph to the right 1. That doesn't seem right, does it? Doesn't seem like subtraction, subtract less, ought to move it to the left. Why does it move it to the right?
Squares.
If you subtract something from the x value, doesn't that mean that it's going to happen a little bit later on the graph because you subtracted 1 from the x value before you squared it? So it's going to happen slower or later? Slower or later on the graph is actually to the right. Does that make sense? So subtraction of 1 really does have the net effect of moving it to the right 1 because it happens a little bit later. So in a left to right mentality of a graph, later means right. So if you add something to it, if this had been plus 1, we would shift it left 1. Why does that shift it left 1? Because if we add 1 to the x value before we square it, doesn't it happen a little earlier than we expected it to happen in our old friend? Earlier on a graph is where? Left, right? Because you do a graph from left to right. So if it happens earlier, its net effect is shifted left. If it happens later by subtraction of 1, the net effect is to shift it right. Assignment for tomorrow. Question first.
Is that only because it's squared?
That's because we're doing that to x before we square it, or whatever the function happens to be. The function might be this one, where we're subtracting 5 from x before we take the square root.
Right.
So that would have the net effect of doing what to this one?
To the right.
To the right 5. So it's before we do what is being done to that variable in the function. I've got something that I'll prepare and put up here tomorrow from the book that will kind of clarify where the plus and minus takes place as to how we shift it, in which direction. But if it's done before we actually insert it into the function, then it has the net effect of going right 1 here, or in this case, right 5. Any other questions before I kind of let you go with your assignment? Assignment is to look at sections 1.1 through 1.3 completely. Figure out what is in there that's not completely review for you or prerequisite material. And we will start class with that tomorrow. And then we'll leave that behind as understood and go on to the appendix in the back of the book in section 1.5. Have a good afternoon. Okay.
Do you have any like tutoring stuff for just in case?